Hi, in this video I'll be talking about the various non-contiguous file allocation techniques. So let me do a quick revision of what the non-contiguous file allocation technique is. So in the non-contiguous file allocation, our storage device is divided into several blocks or several chunks which are called blocks, and each block has a defined size. So right here we have 10 blocks and each block has a size of 5, so it can only have 5 entries. So when we have a file, the file also gets divided into the chunks, and each chunk moves to a particular block. So right here we have two files, the green file and the red file. So the green file it has another world, that's the data that is stored in it, but rather than putting it in one contiguous sequence, we just separate it into we separate it into different blocks. The same thing applies for the red file over here. But yeah, the problem is, how do we link this all together? And that is when we use the various techniques used in the various techniques for non-contiguous file allocation. So the two major techniques are the index allocation and the linked allocation, and these they are implemented differently, but they do the exact same thing. So first of all, let's talk about files in general. Whenever you create a file, what gets stored, the only data that gets stored in the file itself is the starting block, and that's all. The file just knows its starting block, and this file information can also be in your storage device, right? So all the file knows is this file name and the starting block, and probably the metadata, the associated data with it, like when it was created, when it was last modified. But this is like the major thing: the name of the unique identifier for the file and the starting block. So the starting block for this file is block 7. We go over to block 7 and we see it's hello. For the green file, it's block 0. We go over here, we see it's ANOTH. And so these are the starting block. But then how do we connect the entire file together? How do we bring everything together? So one technique, like I mentioned, is index allocation. So in the index allocation, what we use is we use the hash map or the hash table data structure. Each block is a key in the hash map or hash table, or depends on your language. Python is the object. In JavaScript is the object. Python is the dictionary. So right here, each block is a key. Then the value of each block is the next block that it's after it. So let me give you a quick example of how this works. So like I said earlier, our file, all it knows is the starting block, and the starting block is 7. So this 7 here, it has access to the index here. So in 7, if you go over to the index here, 7 has the next block in 7 is 3. So what it does, it goes over to the same index over here. What is 3's index? 3. So from this, we know that the next block after 3 is, the next block after 7 is 3. So if we come over here, you'll see that, okay, 3, hello world, the continuation of it. So 3 we want to get its next block. So we go over here to the our index, and it checks what is the next block. Well, it's 8. So we get the data from 8 and we add it to, we add it up. Then 8 wants to get its next block. Then we come over here and we realize it doesn't have anything. So that tells us we've gotten to the end of the file. The same applies with the green file. First of all, from the file, we get the starting block, which is 0. We get the data. When we've gotten the data, we are now like, okay, what comes next after block 0? Well, from our index over here, it's 4. So we get the data from 4. Then we ask, okay, what comes next after 4? We come over to our index and it's 9. We get the data here. Then we decide, okay, what comes next after 9? We go to our index and it tells us it's no. So we know we've come to the end of the file. So this is beneficial because it's for getting your various file blocks, it has a constant time complexity. So there is no, like, it's just like the hash map. Everything is at a constant time rate. for retrieval of the various blocks. So the second technique is the linked allocation. So in the linked allocation, we were using a hash map. We're using a hash map that has a key values where the block is a key and the next block is the value. But in the linked allocation, we use a linked list, right? Rather than using a hash table or a hash map. So what we store, the same thing, the file just has the starting block. Then each block is basically stored in, just like the linked list, the data of the block is stored there. Like so, for 7, the data is this, but then it also contains the next value, like it's pointing to the next block. So this is 3. We come over here, we see it's 3. Then 3 is also pointing to its next block, which is 8. Then 8, since it's the end of the file, is not pointing to anything. So we just know that, okay, this is not pointing to anything. Then the same thing applies for this file. 0 is pointing to its next block, which is 4. So that completes this thing, this sequence. Then 4 is pointing to its next block, which is 9. And 9 isn't pointing to anything. So we know we've gotten to the end of the file. So these are the two major techniques we use to kind of like bring our various blocks together. We're kind of like organizing the files for the user, which, just like what a file system is an interface between the user and their storage device. A well implemented file system will separate this, the user will not even be aware of what technique is being used. So that brings me to the end of this video. In the next video, I'll be talking about the directory structure. So right now I spoke about how files get stored, but how does directories get stored in a file system?